Assalamu alaikum, dear students. I am Tahir Irfan again with another video short for how to use ICE table. That is a fundamental concept when we have to attempt the questions related to reversible chemical reactions. Okay, I have selected a past paper question that was entirely based upon reversible chemical reactions. The first part is define Le Chatelier's principle. Now, we know that when we understand reversible chemical reaction, there is a forward reaction and there is backward reaction. And when the rate of forward reaction becomes equal to the rate of backward reaction, we say that a particular state of equilibrium has been achieved. Now, suppose there is some chemical reaction that is already in the state of equilibrium and we make any change in the physical state like temperature, pressure, we try to make any change into that particular physical quantity. So what will happen? According to Le Chatelier's principle, if we make any change in the physical conditions when the reversible reaction has achieved a state of equilibrium, so that particular reaction, that particular equilibrium will shift itself in a way so that the effect of the change will be minimized. So proper definition says if a system is in equilibrium and already it have achieved equilibrium and a change is brought about in its physical condition. Physical conditions means temperature, pressure, concentration, etc. The equilibrium shifts in a way to minimize the effect. And this is the point, to minimize the effect of that change. Suppose I give you one example. If a system is in equilibrium and we increase pressure, the equilibrium will shift itself towards the lesser number of gas moles. This particular topic will further be enhanced when we study particularly the synthesis of ammonia. Now, the second part of this question says reaction 1. Now, this is reaction 1. As we can see, describe the reversible reaction between yellow iron 3 ions and colorless SCN anions to produce red colored. This one a complex ion in which there is an iron atom, sulfur, carbon and nitrogen, and it has got a +2 charge. We can see the reversible chemical reaction here. A mixture of iron 3 and SCN and FeSCN +2 is at equilibrium at 20 degrees centigrade. We can also see one more thing, the enthalpy change is negative. It means this is actually exothermic. Now the point is this, we can see two chemical reactions, the forward and the backward. So which one is exothermic? So please remember, we always talk about the forward one. Like this one, this is exothermic chemical reaction where I have written an E. Obviously the backward reaction will be endothermic. Okay, the mixture of the temperature of the mixture is then increased to 50. As you are increasing temperature from 20 to 50, it means you are increasing the amount of heat and allowed to reach another equilibrium. So what will happen? Deduce the changes that occur, if any, in the equilibrium mixture at 50 degrees centigrade compared to the equilibrium mixture at 20 degrees centigrade. First of all, change in appearance. Now we see the forward reaction is exothermic and we are increasing the temperature. So please remember, increasing temperature, if we are increasing the temperature, the exothermic will not be facilitated, it will be reduced. So if we increase temperature from 20 to 50 degrees centigrade, the exothermic chemical reaction will become slower. It means the endothermic, the backward one, this one, it will be facilitated. And if it is facilitated, we would see more yellow color. As more yellow, I have written, a student may write a full sentence that equilibrium will shift towards left, making the mixture more yellow. Listen again. Equilibrium will move towards left side, making the mixture more yellow. Okay, next point. Change in relative concentration of FeSCN plus 2. Now, this comes to the right side. If we are increasing from 20 to 50 and we know that the equilibrium is shifting towards left, it means this one FeCN plus 2, its concentration must decrease. So I have written about decrease because we know the equilibrium is shifting towards left side, so obviously the concentration of the product will be decreased. As the third point, it says change in the value of equilibrium constant Kc. Now please remember, the value of Kc or Kp will only be changed if there is a change in the temperature. As we can see, there is change in temperature, so we can expect there is going to be some sort of change in the value of numerical value of Kc. But please remember, if there is no change in temperature and pressure or concentration or catalyst, whatever the things they are, if those physical conditions are altered but there is no change in the temperature, so please remember that there will be no change in the numerical value of Kc. But for this question, as we can see, there is change in temperature. The temperature is increased from 20 to 50, and we also know that the backward reaction is facilitated. There will be lesser product, so obviously the value of Kc will get reduced. So as we can see here, I have written about decrease, or we can say the value of Kc would decrease.